So we'll start with another interesting and very important review on quantitative analysis that will teach us the concepts of hypothesis testing. So we'll start with the introduction to hypothesis testing and the procedure of hypothesis testing. Very important. If you understand this, the rest of the chapter is just an execution of this initial concept. The two-tailed and the one-tailed test, the Z-test and the T-test. Understand type 1 and type 2 errors that can happen in the process of hypothesis testing, the concept of p-value, and certain other hypothesis tests that you do not need to memorize, but you should know. So a hypothesis is any statement regarding a population. It's a free world. I can say anything I like. And a hypothesis is any statement that I make about the population. The average age of CFA and FRM candidates is greater than 80 years. Is a hypothesis because it is a statement about the population. It may or may not be true. So if I say that the average age of CFA and FRM candidates is greater than 40, then that is a hypothesis about the population. The only way then that you can validate or invalidate the above statement with 100% confidence is by calculating the actual population parameter and comparing it with the hypothesized value. So calculate the data for the population, calculate the average age. If it comes out to be 35, that means the hypothesis was incorrect. If it comes out to be 45, that means the hypothesis was correct. That is the only way that with 100% surety you can accept or reject the hypothesis. Hypothesis testing, however, is the statistical assessment of the validity of a hypothesis at a given significance level that we will do with the help of samples. Now, because it is too cumbersome and time consuming to actually collect data and calculate the parameter for the entire population, what we will do is that we will calculate the statistics for a sample and we will make statements like, because the sample statistic has come out to be so much, the statement looks like it is incorrect, or the statement looks like it is possibly correct. We cannot say with 100% certainty because we only have a sample. But with a sample, we will try to make some inference or some validation of this hypothesis with a given level of significance or a given confidence level. So the most important slide of the review on hypothesis testing, you must memorize the procedure and apply it exactly in the manner discussed for every question on hypothesis testing, and you cannot get a question wrong. So hypothesis testing begins by first stating the hypothesis. That what is it that you want to test? So in the previous example, we wanted to test if the average age is greater than or equal to 40. The null hypothesis that I will explain in the next slide is actually the opposite statement. So the null hypothesis would be that the average age is less than or equal to 40. If we reject the null hypothesis, then we will conclude the alternative that the average age is greater than 40. So that's the first step. That is stating the hypothesis. The hypothesis was that the average age of the population is greater than 40. The second step is to select the appropriate test statistic. Now, this will come from the hypothesis and from the parameter that the hypothesis is on. In this case, the hypothesis is on the mean of a population. And with a large enough sample, we know that mean generally follows a normal distribution. So if the hypothesis is on the mean, then we can use the normal distribution or the Z statistic. If the sample size was small, we probably would have used the T statistic. If it was a hypothesis on the variance or the standard deviation, we would have needed to use the chi-square distribution or the F distribution, as we will see in the coming slides. So second step is to select the test statistic. For hypothesis on means, this would be the Z statistic. The third statistic or the third step is to specify the level of significance. As a researcher, you will determine this by how critical your application is and how much confidence you want when you are rejecting this statement. So this number can be anywhere between 90 to 99%. It will be given in the exam for the purpose of the level 1 or the FRM part 1. But independently, as a researcher, when you go out on your own, the criticality of your application decides what number you will keep. So how confident do you want to be when you reject the null? That will be the confidence level. Level of significance is 1 minus the confidence level. Fourth is state the decision rule regarding the hypothesis that will come from steps 2 and 3. So if we have selected the normal distribution and we have selected a confidence level of 95% or a level of significance of 5%, then 95% of the times the value lies within 1.96 standard deviations of the mean. If the observed value or if the hypothesized value is greater than 1.96 standard deviations from the mean or less than minus 1.96 standard deviations from the mean, that means it is too extreme. It falls beyond the boundaries or it falls beyond the boundaries of a 95% confidence. So 95% of the values lie in this range. So our value, if it is too extreme, then we can reject the null. So we have hypothesized the value is less than or equal to 40. Or if you hypothesize that it is equal to 40, for example, then if the observed sample value comes out to be 80, then it is too extreme. Or if it comes out to be 10, then again it is too extreme. So the fourth step is to state the decision rule regarding the hypothesis. That is, at what value will you reject the null and at what value do you fail to reject the null. With the specified level of significance and with the known test statistic, we can get the decision rule quite easily. So if it's a 95% normal distribution, then for a two-tailed test, and I will explain a two-tailed test, the value should lie within 1.96 and minus 1.96. So for now, just remember the fourth step, that is, state the decision rule regarding the hypothesis. When we do an example, you will understand exactly how this is calculated. Step 5 is collect the sample and calculate the sample statistics. So you hypothesized that the value is less than or equal to 40. Now collect your sample and calculate the age of the sample so that you can make a decision whether the statement is looking like correct or incorrect. So the sample comes out to be 60, it comes out to be 41, then you cannot confidently reject. If it comes out to be 38, then you can definitely not reject the statement. If it comes out to be too extreme, if it comes out to be 80, then you can reject. That we will do in conjunction with the decision rule. So the sixth step is to make a decision regarding the hypothesis from your collected sample statistic and the decision criteria. If you can reject this statement, then with a 95% confidence, you can say that yes, it looks like the mean is greater than 40. Because with a 95% confidence, we have been able to reject the null. And finally, make an economic decision based on the results of the test. So whatever your application was, if your age is greater than 40, then you probably want to hold classes late in the evening because people have other obligations, etc. If it is different, then you may want to keep the sessions too early or in the morning, depending on whatever your requirement is. So seventh step is do the economic purpose for which you are doing the test. Normally we won't be doing it just for fun. There'll be some reason why we are making a statement and why we want to test that statement. So anyways, at this point, the idea is just to remember those 7 steps. Once we do a couple of questions, the steps will become absolutely clear. But step 1 is to state the hypothesis. Step 2, select the test statistic that will come from what the hypothesis is like. On the mean, it will normally be the Z statistic. State the level of significance, that is how confident you want to be when you reject the null. State the decision rule regarding the hypothesis that will come from the confidence level and the test statistic. So what is considered too extreme? Collect the sample and calculate the sample statistic, that is the mean of a sample, and then compare it with the decision rule and make a decision regarding the hypothesis, and finally use those results in your economic application, whatever it may be. The null hypothesis, remember, is the hypothesis that the researcher wants to reject. So in our question or in our example, the statement was that the average age of CFA and FRM candidates is greater than 40. So we want to test if the age is greater than 40. That is, do we want to reject this statement? That is the null hypothesis. The null hypothesis is the statement that the researcher wants to reject. That is, the mean is less than or equal to 40 is what he wants to reject. It is the hypothesis that is actually tested and is the basis of the selection of the test statistic. So we will see if the null hypothesis is on the mean, then we will use the test statistic as the Z statistic or the normal distribution. If it is on the variance, we'll probably use the chi-square statistic, as we will see. Typical statements include mean is equal to mu naught or some value, mean is less than or equal to 40, mean is greater than or equal to 40. These are some common examples of how the null hypothesis is structured. So mu is the population mean, mu naught is the hypothesized value of the population mean. One property you must always remember is that the equal to sign always comes with the null hypothesis. The equal to sign will always come with the null hypothesis. There may be 4 alternatives or 3 alternatives on the exam that give you some hypothesis and say which one best fits the null hypothesis. The one with the equal to will be the right answer. Equal to sign always comes with the null hypothesis. Alternative hypothesis, called HA, is what is concluded if there is sufficient evidence to reject the null. So if I am able to reject the null, then I conclude the alternative. It is the alternative that you are really trying to assess or that you are testing for. So this is step 1 of the problem, that is called state the hypothesis. Means you have to tell them 2 statements, the null and the alternative. In a two-tailed test, the null hypothesis is of the form mu is equal to something or variance is equal to something. If the null hypothesis is an equality, then you know that it is a case of a two-tailed test. The reason we say it is a two-tailed test is because rejection can happen because of extremities on either side. I am estimating that the mean is equal to 40. 80 will also make me reject. 10 will also make me reject the null hypothesis. So that's why it's called a two-tailed test. So if the test statistic is greater than the critical value, then also you reject the null. If the test statistic is less than the lower critical value, then also you will reject the null. For example, with a 95% two-tailed test and a Z distribution or a normal distribution, the critical value comes out to be 1.96. For a 99%, the critical value comes out to be 2.575 to be precise. For a 95% confidence, it's already mentioned. What are you thinking, guys? It's already given, no? 95%. For a 90% confidence, means I will leave 5 on this side and 5 on the other. So it will be 1.645. So these are some values that you must remember for the Z test. The test statistic is calculated as the sample mean or the sample statistic minus the hypothesized value divided by the standard error of the sample statistic. So if the hypothesized value was 40 in our case, and we collected a sample and the sample statistic or the sample mean came out to be 50, and let's say the sample standard error is equal to 10, then the test statistic would come out to be 50 minus 40 divided by 10, that is equal to 1. So our hypothesized value was 40. With a 95% confidence, the critical value to reject the null was plus minus 1.96. The observed test statistic came out to be 1. Will we be able to reject the null? No, because to reject the null, the value has to be either greater than 1.96. So we are hypothesizing 40. What has come is 50. Question is 50 too extreme? 50 is too extreme if it was greater than 1.96 standard deviations. So 50 is only one standard deviation away. So with a 95% confidence, I cannot reject the null, or I cannot say that I'm 95% sure that this null hypothesis is wrong. It still may be wrong, but with 95% certainty I can't say. If the standard error, for instance, was not 10, it was only 5, the test statistic would have come out to be 2. Then we would have said that for a variable which has a standard error of only 5 and the hypothesized value is 40, if the observed value is 50, then it doesn't look like that the mean is 40. Mean is different from 40, or we can reject the null that mean is equal to 40 because it is 2 standard deviations away. So what we are trying to do is that we've made a hypothesis and we are trying to check that with a particular degree of confidence, can we reject this statement or not? We will reject it if it is too extreme. Too extreme comes from the critical values from the distribution, that is the test statistic. For a normal distribution, 95% two-tailed test is plus minus 1.96. 90% two-tailed test is 1.645. 99% two-tailed test is 2.575. Standard error is calculated as sigma by root n, as we just saw in the review on sampling. And if the population standard deviation is not given, then we will use the sample standard deviation as a proxy that is S upon root n. An analyst has gathered the following data as regards the daily returns on a bond portfolio. The period is a recent 360-day period, and the mean daily return is 0.05%. The sample standard deviation of the daily portfolio returns comes out to be 0.16%. The analyst is of the belief that the mean daily bond portfolio return is not equal to 0. Construct a hypothesis test of the analyst's belief at the 5% level of significance. So the question is on constructing a hypothesis test. So we will follow the 7-point procedure that we just studied. Step 1 is to state the hypothesis. The null hypothesis is a statement that the researcher wants to reject. He wants to reject that the mean is equal to 0 such that he can imply the alternative, or he can conclude the alternative, that the mean is different from 0. He wants to test if the return is not equal to 0. So that will be the first step. Let us state the hypothesis, the null and the alternative. The second step is to select the appropriate test statistic. It's a 360-day period. The hypothesis is on the mean, so we will choose the Z statistic, or the normal distribution. The third step is to specify the level of significance. The level of significance is given to be 5%. So alpha is 5%, or the confidence level is 95%. Step 4 is to state the decision rule regarding the test. The decision rule is, for a 95% two-tailed test, if the observed test statistic is either greater than 1.96 or it is less than minus 1.96. So if test statistic is greater than 1.96 or less than minus 1.96, then we will reject the null. Then we will reject the null. Step 5 is to collect sample and calculate the test statistic. So that's what has been given to us. So what has been given to us right at the beginning is actually step 5 of the overall process. After we have stated the hypothesis and specified everything else, will we go and collect our sample. So the mean came out to be 0.05. The test statistic is calculated as the observed value minus the hypothesized value divided by the standard error. The observed value is 0.05. The hypothesized value is 0. The standard error is not given to us. The sample standard deviation is given to us. So sample standard error can be calculated as 0.16 divided by square root of 360. So this will give us the test statistic. So we'll first compute the standard error. That will come out to be 0.16 divided by root 360. So press 360, press square root, store it in 2, recall 1 divided by recall 2. So 0.00843 is the standard error. We'll store it in the memory register 3. The test statistic can be calculated as 0.05 divided by recall 3, which comes out to be 5.92, or approximately 6 standard deviations away from the mean. So the test statistic has come out to be 6 units, whereas the critical value was 1.96. So step 6 is make a decision about the test. As 5.92 is greater than 1.96, we should reject the null. And we conclude that the mean actually is different from 0. Or 0.05 tells us that we can reject the null and conclude that the mean is different from 0. Step 7 is to use this for our economic purpose, whatever it was. It hasn't been mentioned in this question. So that's the 7-step process that you will follow for every question on hypothesis testing. If you follow it in a sequence like this, probability is very low that you will get the question wrong. So remember the 7 steps and apply it as is to conclude the interpretation. We'll now go on to understanding the one-tailed test. So we would know that the test is a one-tailed test if the null hypothesis takes the form mu is less than or equal to a particular value, and the alternative is the mu is greater than that value, or if the null is of the form that mu is greater than or equal to some value, and the alternative is that the mu or the hypothesized value is less than a particular value. Now in such a case, for example, let's look at the first hypothesis. So we are hypothesizing that the mean is less than 40, for example. So it's less than or equal to 40. If it comes out to be 2 units, will we reject the null or will we definitely fail to reject the null? If the null hypothesis is of the form that mu is less than or equal to 40 and the observed value of the sample mean comes out to be 2 units, will I reject the null or will I definitely fail to reject it? We will definitely fail to reject the null because 2 is much lower than 40 and that is what we are hypothesizing. So in such a case, rejection region will entirely lie on the right hand side. So if we have a 5% level of significance, then unlike the two-tailed test where we split it into 2.5 this side, 2.5 because rejection could have happened either side, if we want to be 95% sure and 5% of the times reject the null, then that entire 5% will lie on the right hand side. So we have to leave 5% on the right hand side. So the value for a 95% one-tailed test will be the same as that of a 90% two-tailed, because even in a 90% two-tailed we would have left 5% here and 5% on the left, which is equal to 1.645. So remember, for a 99% one-tailed test, the value would have been equal to 2.33. For 99% two-tailed, it was 2.58 because you were leaving only 0.5. Now you will leave 1% on this side. For a 90% one-tailed test, the value would be equal to 1.28 because entire 10% is being left on the right hand side. You're not leaving 5 here and 5 this side. So the rejection region entirely is on one side. If the null was mu is greater than equal to 40, then the rejection region would have entirely lied on the left hand side. Values would have been the same, only they would have been minus 1.28, minus 2.33, and the extreme would have been on the left. So the process of testing remains exactly the same. If you see the null in this format, then you know it is a one-tailed test. Only thing that will change is the critical value. The critical value would not leave half of the significance on either side. The entire significance level has to be left on one side. Hence the critical values will reduce as compared to a two-tailed test. An analyst has gathered the following data as regards the daily returns on a bond portfolio. The period is the same, the mean daily return is the same. The sample standard deviation of the daily portfolio returns is also the same. The analyst is now of the belief that the mean daily portfolio return is positive. Construct a hypothesis test of the analyst's belief at a 5% level of significance. Step 1 is to state the hypothesis. So the null hypothesis is that the mean is less than or equal to 0. This is the statement that the researcher wants to reject. So the null hypothesis is that the mean is less than or equal to 0. The alternative hypothesis hence would be that the mean is greater than 0 or the return is positive. This is what will be implied if we have significant evidence to reject the null. Step 2 is to select the test statistic. So we will use the Z distribution or the Z statistic since it's greater than 30, the sample size, and it's a hypothesis on the mean. Step 3 is to specify the level of significance, which is given to be as 5% or a confidence equal to 95%. Step 4 is to state the decision criteria. Now the belief is, rather the null hypothesis is that mean is less than or equal to 0. So we will reject the null if the value is significantly positive. So 5% is the rejection region, and the rejection region entirely falls on the right hand side, so that the critical value, as can be calculated from the Z table, will come out to be 1.645. So if the test statistic comes out to be greater than 1.645, then we reject the null. Please note, otherwise we don't accept the null. Otherwise we fail to reject. So we cannot confidently say otherwise. So we are not saying that it is definitely less than or equal to 0. All we are saying is that we cannot reject the possibility at a 95% level of significance. So if test stat is greater than 1.645, you reject the null. Otherwise you fail to reject the null. We don't accept it. We are not saying that mean will be less than or equal to 0. We just cannot deny that possibility. So we fail to reject the null. If it is less than 1.645, greater, we will reject the null. Step 5 is to collect the data and calculate the sample statistic. So the mean came out to be 0.05. The test statistic is calculated in the same manner, that is the observed value minus the hypothesized value divided by the standard error, that is 0.16 upon square root of 360, that again comes out to be approximately 6 units. Step 6 is to make a decision about the test. As 6 is greater than 1.645, we will reject the null, and we will conclude that the mean is greater than 0, or we conclude that returns are positive, and we will use it in whatever application we have. So this is the 7-step process of constructing and completing a hypothesis test.